Hi, welcome to Automotive Appreciation. In this course, we will learn about the operation of cars. Topics include engines, transmission, steering, suspension, brakes, and electrics. We start with a four-stroke engine in operation. Intake, a mixture of fuel and air is drawn into the cylinder. Compression, the piston compresses the mixture. Combustion, compressed gas is ignited by a spark plug, and exhaust, burnt gases are expelled from the cylinder. Note, the camshafts which operate the valves only rotate at half the speed of the crankshaft. This is achieved by using larger diameter pulleys on the camshafts. The timing belt ensures that the valves open and close at the correct time relative to the position of the piston. We take a look at the engine components. At the top we have the camshaft, which controls the inlet valve, allowing fuel and air into the cylinder. The block houses the main components of the engine and is cooled by the water jacket. Oil is stored in the sump and is used to lubricate the engine. The crankshaft is supported by bearings at the bottom of the engine. The cylinder liner provides a smooth surface for the piston to move inside, while the conrod connects the piston to the crankshaft, thus converting reciprocating motion of the piston to rotational movement of the crankshaft. At the top is the head gasket, which provides a seal between the block and the cylinder head. The exhaust valve is also controlled by a camshaft. It allows the waste gas to exit from the cylinder. Finally, at the tip of the spark plug, the high voltage electricity jumps across the gap and ignites the fuel. It's important to change the timing belt at the recommended service intervals. Here we will see what happens if the timing belt breaks. That's an expensive repair. We must remember a four-stroke engine only provides power on the combustion stroke. The other three strokes actually take power from the engine. To account for this intermittent supply of power, it is normal to have a number of cylinders in the same engine. In this case, a four-cylinder engine. All cylinders will have staggered combustion strokes. For this engine, the firing order is 1, 3, 4, 2. This firing sequence is used to reduce the engine vibration. A flywheel is attached to the end of the crankshaft to reduce pulsations and vibrations. A pulley is attached to the other end of the crankshaft, which can be used to drive ancillary equipment such as the alternator, water pump, or timing belt. Chapter 2, Transmission. To allow safe operation of the engine, it is necessary to separate the drive from the driven wheels. This is achieved with the clutch. The clutch is attached to the flywheel, and it allows connection and disconnection of the crankshaft output. The driven plate is sandwiched between the flywheel and the pressure plate. When the clutch is pressed, the release bearing moves and the driven plate travels along the splint shaft away from the flywheel, allowing the driven plate to rotate independently of the flywheel. We see when the clutch is pressed, the driven plate can move independently of the flywheel and pressure plate. A gearbox is used to vary the shaft torque depending on driving conditions. High torque for accelerating, low torque at cruising speeds. Here we show a basic 4-speed and reverse gearbox. It consists of a number of gears, wheels, which can be intermersed when required. Input shaft from gearbox. At the bottom is the lay shaft, which transmits power through the gears. A small pinion for reverse and an output shaft connects to the driven wheels. Now we will move up through the gears using the selectors. First gear starts with the smallest gear on the lay shaft. Second gear uses the bigger gear, and again for third gear a bigger gear is used. We see that fourth gear is straight through. The crankshaft is connected directly to the output shaft. Some cars have an overdrive, which means the output shaft is rotating faster than the crankshaft. This is sometimes used for fifth and sixth gear. For reverse, an additional pinion is inserted to provide rotation in the opposite direction. Chapter 3: Steering System. The steering wheel is connected to the rack and pinion, which converts steering wheel rotational movement to lateral movement. The final connection to the wheels is made with the track rod and track arms. We see that the inside wheel must turn in a smaller radius than the outside wheel. Also, the outside wheel must travel a longer distance than the inside wheel. On a back-wheel drive car, the differential in the back axle allows for the difference in speed. Here we can see the rack and pinion in operation. Chapter 4: Suspension System. The suspension on a modern car uses springs and dampers. When a coil spring is compressed and released, it will return to its original length. A damper or shock absorber is used to damp down the oscillations of a spring. It consists of an oil-filled chamber, and the flow of oil through the piston is restricted by a small orifice. When the top rod moves down, the gas below the bottom piston is compressed to allow for the extra rod volume. A spring and damper are often combined in one unit called a McPherson strut. Here we see the McPherson strut in operation. It provides comfort for the occupants and maintains the wheel in contact with the road. When a car is moving, it is important to have a safe, reliable means of slowing it down and stopping it in an emergency. This is achieved with a hydraulic braking system. The disc is attached to the wheel and the brake pads are accommodated in the calipers. A reservoir provides a supply of oil to the master cylinder. When the brake is pressed, the piston pressurizes the oil and activates the wheel chambers, clamping the wheel disc between the pads, thus slowing down the wheel rotation. Chapter 6: Electrics. To start the car, the battery provides power to the electric motor, which starts the engine rotating via a connection to the flywheel. When the engine is running, the alternator driven by the crankshaft ensures that the battery is maintained in a fully charged state. Power from the battery is used for various electrical systems. Fuses provide a protection for each individual circuit and switches allow current to flow. When we start the engine, a pinion on the starter moves forward and engages with the ring gear on the flywheel. Now the alternator supplies power to the battery and electrical circuits, and switches allow current to flow. We hope you learned from Automotive Appreciation.